Hello everyone, this is Team F and our project revolves around churn prediction modeling for a telecom operator. So what exactly do we mean by churn? It basically refers to the number of customers lost in a given period of time. It's important for companies to measure and keep track of churn rate, as for sustainability the churn rate must be kept lower than the growth rate. There are three key factors that lead to customer churn: dissatisfaction with the services offered by the firm, and better offerings and targeted marketing efforts by the competition. So why do we need to worry about churn? The main reason is to retain existing customers, as acquiring new customers has acquisition costs associated with it. Retention can also help in increased service consumption and referrals, which in turn translates into higher revenue for the firm. Various modeling techniques can be applied to churn data in order to predict customer churn and thus target efforts to retain them. Another useful application can be to identify factors contributing to churn and act on the same. Our prediction model follows the shown path. We start with identification of the underlying business objective, which in our case is to predict customer churn. Next, we gather the required data and clean it for processing. Decision tree and information gain is then used to identify the important features leading to churn. These selected features are used for classification of the customers into two sets based on their likelihood to churn. We then looked at the churners and tried to segment them into different geographic clusters. Based on the results obtained, we came up with a set of recommendations for the telecom operator. We sourced the data from Crowd Analytics, which is a crowdsourced data analytics platform. The data provided customer usage pattern along with an output variable describing if a customer churns or not. In total, we used 3,333 records with 15% churn instances. Looking into our dataset, we observed class imbalance, that is bias towards non-churners with only 15% churn instances. Thus, to obtain accurate results, we used synthetic minority oversampling technique to have a roughly equal split in the data. Using information gain-based decision tree, the most important variable for churn prediction is number of call minutes spent during daytime. The next set of important features were number of customer service calls in a day and if the customer had a voicemail plan. Other important features were presence of an international plan, call minutes during evening time, minutes spent on international calls, and the number of international calls made in a day. We used 10-fold cross-validation and looked at 6 classification models: naive Bayes, Bayes net, all-dimensional tree, SVM, logistic regression, and random forest. In addition to looking at the accuracy levels for all models, we also plotted ROC curves using true and false positive rates to obtain area under the curve values for better model predictions. In line with the accuracy values, the AEC values also turned out to be highest for random forest and AD tree. Looking at precision and recall values for all the models, we can again see that random forest and AD tree models outperformed others. Our next step was to look at the churners and obtain geographic clusters. Customer segmentation for churners showed that big states like California, Texas, and Montana had a higher churn rate as expected due to fierce competition. On the other hand, smaller states with less competition like Iowa and Arizona showed lower churn rates. We tried analyzing churn rates in relation to account length for customers. We found that the period between 91 to 119 days experienced the highest amount of churn. Thus, we can conclude that after 119 days, customers tend to progress towards becoming company loyals. Another aspect we looked at was call minutes related to call rates being offered. We can see that during evening the churners tend to talk less compared to non-churners. Using the currently offered rates, the churn rate in our data was 15%. Thus, we looked at decreasing the rates for day and night when the churners talk more and increase the rate for evening when they talk less. This reduced the churn rate to 11.5%. Finally, we have 3 major recommendations: modify strategies in competitive states, target efforts between 91 and 119 days of account length, and tweak the call rates based on time of day and associated call duration for churners.
Created using Powtoon.